Hi, welcome to this lecture on mathematical methods. Today we will discuss plotting a function, and the question that we will answer in this lecture is, what is the recipe to sketch a function? We have learned many things about mathematical functions, and recently we learned about derivatives, first derivatives and second derivatives. We learned that the second derivatives give us the curvature. So, using the idea from what we learned so far, we will learn about plotting curves. So, what we will learn is how the ideas from calculus that we learned so far can help us in plotting functions. So, this is we would learn, and the hint is we can now figure out locations of maxima and minima, something that we learned after learning second derivatives. So, first question is, what are the minimal details that we need to sketch a function? So, now the question is, what are the minimal details needed to sketch the shape of a function? So, function, we do not know how the shape would be, but what are the minimal things that we need to know? So, the details would be that if we know the starting and ending point of a function, if we know the beginning value and the ending value of a function, that would be the first thing needed. So, if we think about it, we want to plot, let us say we want to draw from 0 to some large value of x, and one thing we know is that at 0, at very small value of x is somewhere here is a very large value of the function. Function has very large value, and when x is very huge, the function would reach almost 0. So, if this is the, if you know the starting point and ending point, so this is the starting point, and ending point. There could be many curves which would satisfy this. I could draw a straight line, or I could draw many kind of curves. Then what we want to know after that is that, does the curve turn at all? Is it a straight line, or is there some turns? So, now second thing we would want to calculate, first after you understand turning point and ending point, we would calculate whether there are any turns. So, if the function is, one possibility is just a straight line. If it is not a straight line, it could have some curves like this, right? It could have a starting point, it could have some turns. So, does this curve have turns or not? So, turning points. So, these turning points would be typically maxima or minima, right? So, these are the points where the function is coming down and is going to turn here. So, to turn this, these turning points are maxima or minima, and there are some way of finding out maxima or minima. So, turning points or maxima or minima. So, we will understand how each of this can be found, and then we have to know what kind of turning points does it have. I could have different kind of turning points. I could have a similar curve, exactly similar, very similar curve, but with a different behavior. Let us say I could have some function which is like this, which is a starting point here and ending point here. Instead of like this, I might have the function like that, or something, we do not know. So, in other words, the turning point here is different from the turning point that we had drawn previously here. So, the nature of the turning point, it is a maxima or minima, and where are the turning points? So, nature of maxima or minima, turning points, right, which would tell whether it is a maxima or minima. There could be turning points of different kinds, and the location of the turning points. So, if you know this kind of stuff, we would be able to draw different curves. So, now let us take some example and think about it. So, the point here is that these are the factors that you would typically minimal details that you would like to know. Know the starting and ending values of a function. If you know this is important to know this. Calculate how many times does it turn, right? So, that is essentially the curvature. What are the turning points? Like where are the turning points? What is the locations of the turning points? What kind of turns are they? Are they maxima or a minima? Maxima or a minima or maxima or minima? So, these are the details that you would want to know. So, let us take a simple example, right. So, let us take some simple function f of x is equal to x cube minus x. So, I would write that is our function, or you could write y of x is equal to x cube minus x. So, whether you like x of y f of x or y of x, both are same representation. So, now if you want to think about this function, let us consider this function, which is our f of x is x cube minus x. This is our function. Now, first thing we want to know is that where is this function? If you think of this as a plot, what are the values of this function at different? So, whether we could plot this from minus infinity to infinity. So, let us say minus infinity to infinity, minus infinity far away to infinity, we could plot this, or we could plot from 0 to infinity. Depending on what we want to plot, we would have different starting point. So, let us say if we want to plot from minus infinity, first thing we want to know is that what is the value of this function at minus infinity. So, when f of x when x is, what is the value of f of x when x goes to minus infinity, and what is the value of f of x when x goes to plus infinity. These are the first things you would want to know as the starting point and the ending point. So, if you look at it, surely as x goes to infinity, x cube will be larger and larger and larger. If substitute first 1, so it will be 1 cube minus 1 is 0. If it is 10, 10 cube minus 10 is a huge number, 1000 minus 10 is like 990. If it is 100, 100 cube minus 100 is a very large number. So, as x tends to infinity, this f of x value will also go to infinity. This is clear from this. Now, if x is minus infinity, right, as x goes to minus infinity, what will happen? So, when x is very small, minus infinity cube. So, if it is minus, x is minus 10 cubed is a huge negative number, minus 10 will be plus 10. So, this will be the dominating term always. So, if x is highly negative, x cubed will be also a large negative number and will be much larger than x. So, it depends as x, since x cube would go to minus infinity as a function, the function also will go to minus infinity. That is, as x goes to minus infinity, x cube will go to infinity. Therefore, f of x will also go to minus infinity. So, we understood the 2 points, the starting point and the ending point. At minus infinity, the function is minus infinity. When x is plus infinity, the function is plus infinity. So, let us take this paper and mark this properly. So, our function is f of x is x cube minus x. Now, we are going to draw this from minus infinity to plus infinity. So, minus infinity far away here and plus infinity far away here. And what we found is that at minus infinity, in the limit as x going to minus infinity, the function is minus infinity. In the limit x going to plus infinity, in the limit x going to plus infinity, the function is value infinity. So, here the value is minus infinity, some large negative number. So, this is one of my starting point, and as x goes to infinity, here I will have a large positive value. So, I have to grow from here to here, and I can think I could draw this in many different ways. From here to here, these 2 points, I could draw this many different ways, but that is not enough now. Now, we want to know whether this has any maxima or minima, any turning points, right? Whether will it go like this and turn and come down, or will it just directly go? So, the first thing is whether will it turn, right? That is the first thing we want to know. If it turns, where will it turn, right? So, let us think about this question. So, how do we find out the turning points? So, this is the thinking, finding turning points. In other words, maxima or minima. When the function f of x, so what we know is that if at maxima or minima, wherever there is a maximum or a minimum, the df by dx will be 0. This would imply maxima or minima. We do not know what it will be, but both at a maximum or a minimum, the first derivative will be 0. So, if you take this function x cube minus x and calculate first derivative, it is going to be 3x square minus 1. In other words, and where will this be 0? So, 3x square minus 1 equal to 0, which means df by dx is 0. This would imply that x is equal to plus or minus root 1 by 3. 3x square is 1, x square is 1 by 3, and x is root of 1 by 3. So, there is the two roots, plus 1 by 2 and minus 1 by 3 root, plus 1 by 3 root and minus 1 by 3. So, these are the 2 points where there are 2 turning points we will have. So, we have 2 turning points, which is basically 1 by 3. So, let me draw here this as 1 by 3, and this is also, so this is plus 1 by, so this is minus 1 by 3 root, and this is plus 1 by 3 root. So, these are the 2 points the function will turn. Now, if it has to turn here, how many ways, what are the ways, you draw different ways this would happen, but the function has to come and it has to turn here, and it has to turn here and go. So, now this could happen in different ways, but this would roughly give us the shape of the function. So, the rough shape of the function would be just to come somewhere, turn here, and then go and turn again back here. So, now itself we can draw the rough shape of the function, even though we may not be able to draw this precisely. So, now next question is in this turning point and in this turning point, whether it is going to turn upside down or down up, right? Is it a positive curvature or a negative curvature? That is something which we have to still find out. Second derivative will tell us whether it is a positive curvature or negative curvature, but let me just guess. If it is, the function is going to start like this and it has to turn at this point and there is no turning point before this, right? There are 2 turning points only. It has to go, then it has to it can turn down. So, if it comes like this, it has to turn like this here. That is clear. And if it turns here, this has to turn back here. So, these things are clear that you can guess, that I am guessing that it is going to be like this. It is going to turn here like this and then turn here like this and go like this. This is some guess that I am making, but we have to confirm this guesses, that if this is starting here, I am going to make a turn here, and only 2 turns it has to turn like this, and then it is going to come and turn again here and then reach the value. This is one possibility. of course, we have no way of knowing whether it will turn. At the moment, we don't know whether it will turn here or will it turn below 0, will it cross 0 here, will it cross 0 here. This could be, the places where it is crossing 0 could be horribly wrong. But the shape could be rough like this is something that I would guess at this moment without doing much of the calculation, right. So, let us now understand this in detail, where the turning points are and what are the values and all that. So, for this we have a very clear recipe, instruction and instruction set. It's like a set of instructions. So, what is the recipe for sketching the function f of x? Evaluate the f of x at 3 points. So, at infinity, minus infinity and 0. So, this would help us, even though we haven't done it so far, the function at 0 will help us plotting it more precisely. Find out the points where the function is crossing 0. So, when f of x equal to 0, if you know the point where the function is 0. So, let us come back here. We want to know where the function x cube minus x will be 0. That means x cube is equal to x, which would mean, right, which would mean that this is possible. 1 it is 0, both are 0, x is 0. When x is 0, x cube will be equal to x. So, one possibility is x equal to 0. When x is equal to 1, of course, this is 1 cube is 1. So, this another possibility is x is 1. So, at 0, so what I have drawn here is not fully correct, because this has to cross at 0. The function will hit 0 at 0. That is what this would imply. Then it will hit at 1. So, this point is likely to be 1. It will be a 1, right, and it has to hit one more place 0, because it will have 3 roots. So, one root is this, the one root is 0, the other roots are x square is equal to 1. So, x is equal to plus 1 and minus 1, x is equal to plus 1 and minus 1, this will be minus 1. So, if I cancel 1 x, this will be x square is equal to 1 and this will have minus 1 and plus 1. We will see this. So, to do this, to see this, let us go ahead and understand this, but this is important of find out the points where the function is 0, calculate the points where the function has maxima and minima, that is, you calculate the df by dx equal to 0, find out which one is maximum, that is, where is d square f by dx square less than 0, and which one is minimum, d square f by dx square is greater than 0, evaluate the function at maxima and minima, make a schematic sketch using the above information. This much information will help us to make a nice schematic sketch. So, let us do this step by step. First, we have to evaluate the function at 3 points, infinity, minus infinity and 0. And as we saw, this x cube by 3, so we will do a different function here, x cube minus 3x, right. So, let us take this function x cube minus 3x. So, if you take this function x cube minus 3x, similarly at infinity, when x is going to infinity, this function also has infinity. When x is going to minus infinity, this function will have minus infinity. When the function is 0, this function will, when x is 0, the function will be 0. When x is infinity, the function is infinity. When x is minus infinity, the function will tend to minus infinity. When x tends to 0, the function will be 0, right. So, these are the limits that we have. So, we know the starting points and ending points. Now, we want to find out the points where the function will be 0. So, note the function is slightly different here, is x cubed minus 3x. So, we want to find out the values of x at which x cubed minus 3x is 0. So, when x is 0, x cubed minus 3x is 0. When x is plus root 3, this function will be 0. When x is minus root 3, the function will be 0. As we know, like if you have this function x cubed minus 2x, 3x. So, let us take this function that we have, which is x cubed minus 3x. This is our function, and this would, if this is equal to 0, implies x cube is equal to 3x. This is what it implies, right? This would imply x equal to 0. When x equal to 0, this is possible. Otherwise, if this is also possible when x square is equal to 3, that is x is equal to plus root 3 or minus root 3. So, these are the two places where this would be 0. So, now then you can calculate the first derivative. The first derivative is df by dx is equal to 0. You can calculate the first derivative of 3x square minus 3 equal to 0 is the first derivative, and you equate this to 0 and solve for x, and you will find that x is equal to plus 1 and minus 1 are the 2 points. This have 0, that means at these 2 points the function will turn. So, these are the 2 turning points, and you calculate the d square f by dx square, and at these turning points, what is the d square f by dx square? So, let us quickly look at this d square f by dx square. So, you have f of x is x cube minus 3x, and df by dx, the first derivative, is 3x square minus 3. The second derivative, d square f by dx square, this is 0, so the derivative of this is 6x. So, the second derivative is 6x. So, now we know that the turning points are x equal to plus 1 and x equal to minus 1. These are the maxima minima points, and when x equal to plus 1, this would give 6 at x equal to plus 1, and this would give minus 6 at x equal to minus 1. So, when x is minus 1, the value second derivative is negative. When x equal to plus 1, the second derivative is positive. So, this is what it is. When x equal to plus 1, the second derivative is, since it is a positive, it is a minima, and when x equal to minus 1, the second derivative is, it will give us that the function has a maxima. So, now if you want to sketch, evaluate the function at x equal to plus 1, x cube minus 3x equal to minus 2, and you can calculate these values. At x equal to minus 1, x cube minus 3x is 2, and then we plot this, and what we would find is that it will start from minus infinity, and it will come up, and it will turn here at minus 1 here, and it will come and again turn here back, and then it will go to 0, and here there is at minus 1 there is a maximum, and at plus 1 there is a minimum. So, this is the recipe to plot any function. So, to summarize, what we have is that to plot function, what we are going to learn, we learned is about how to sketch a function. So, sketch the shape of a function. We may not know all the points precisely, but we would know the rough shape of a function by following this recipe. So, for which we have to use ideas from calculus, like the idea of maxima, minima, derivatives, that the idea that the first derivative 0 would mean there are maxima, there are turning points, there is maximum or minimum, or maxima or minima, and whenever the second derivative, if the second derivative is positive, it will be a minima, and when the second derivative is negative, it will be a maxima. So, these are the ideas from calculus that we learned, which we could directly apply and learn about how to plot, how to sketch a function, and this is going to be extremely useful when we have to use these mathematical ideas, the mathematical equations to describe some biological phenomenon. How would things vary in a cell? This function could be concentration. So, where is the concentration high? Where is the concentration low? How is the concentration profile would look like in a cell? If we want to know all these details, what is the shape? Where is it curved? Whether it is curved or not? If you want to understand these things for a biological system, this would be extremely useful for us. We would discuss some of these examples soon, and therefore, with this, so it is important to learn this. With this, I will stop today's lecture. See you later.